In topics 1 and 2 of section 4.3, we learned how to find exact values of trig functions using the definitions and a right triangle for which we had at least two of the sides. As you've heard me say in class, anything worth doing forward is worth doing backward. So here we're going to learn how to construct a right triangle given the value of a trig function, and then use that to find the values of the other 5 trig functions. So to introduce this, we're going to use problem 13 from page 280, which you'll want to include in your notebook as an example problem. So starting out, we're given that sine of theta is 5/6, and we're asked to sketch a triangle that goes with this. So we have a right triangle with the angle theta. Since sine of theta is opposite over hypotenuse based on the definition on page 273, then we know that 5 is the opposite, so we can put that on our triangle there. We know that 6 is the hypotenuse, so we can put that on our triangle there. And all that we're left not knowing is what is the adjacent side. But from the Pythagorean theorem, we know that the hypotenuse squared is equal to the adjacent side squared plus the opposite side squared. Or, solving that for the unknown adjacent, we have hypotenuse squared minus opposite squared is equal to the adjacent side squared. Or, square root of h squared minus o squared is equal to a, which is what we're looking for, the adjacent side. So let's go ahead and solve that. We have the square root of 6 squared minus 5 squared is equal to a squared, which is 36 minus 25 is square root of 11. And no, that is not squared. So now we have our complete triangle where the opposite side is 5, the hypotenuse is 6, and the adjacent side is square root of 11. Now we want to keep that as square root of 11, not as a decimal approximation, because we're looking for exact values, which means fractions and radicals, not decimals. Unless the decimal can be used to exactly represent the fraction, a decimal approximation is not acceptable. So 0.5 is okay instead of a half, 0.25 is okay instead of a quarter, but a decimal approximation of square root of 11 is not acceptable for an exact value. Now, for this triangle, we know that sine of theta is 5/6 because we were given that. We can write that the cosecant of theta equals 1 over the sine theta is equal to 6/5, because that's the definition of cosecant. Cosine of theta is equal to adjacent over hypotenuse, which in this case was square root of 11 over 6. Secant of theta is 1 over cosine theta, so that means it's just 6 over square root of 11, the reciprocal of what we just did. And tangent of theta is opposite over adjacent, which is 5 over square root of 11, and cotangent of theta is 1 over tangent of theta is square root of 11 over 5. And this gives us the 6 trig functions for that angle that we started with just knowing that the sine of theta is 5/6. Now I encourage you, when you do one of these, build this table pretty much the way I have it here. If you start with sine and cosine and tangent, one of the things that's helpful about that is sine over cosine is tangent, so you already have that constructed to get what you need at the bottom. And then when you go to the side, you can just do the reciprocals. So no matter which one of these you have, you can always find the reciprocal and then sketch it into the triangle and find the rest of your solution. Hopefully that's helpful in establishing how you do the rest of problems 14 through 20. Be sure that you copy this into your notebook as the example for this objective and use your stars and question marks.